Okay, Vivek and Jayashankar, I believe you are having a school up to class 12 and you teach in all subjects that range from humanities to commerce to sciences. Am I right? Both medical and non-medical science. All right. So I am actually trying to take it how we are analyzing data. By and large, we do not use data literacy much into any other subject, barring computer science. But what we believe is that there is a tool which actually can help your students from class 6th or 7th onward, and we can bring in data literacy on a level which was never possible before this. So I introduce you to CODAP. That is a tool that we actually are using on MethdAI. Right. We'll start with a very short presentation. I hope you can see my screen.
Yes, sir, it is visible.
Okay. In the meanwhile, I'll have to actually ask Mr. Vivek and Mr. Jayashankar, would it be okay that if we speak, I mean, can you, if you have a query, would you be able to type it? Okay, after the session. Fine, perfectly fine. No worries. So I'm going to my presentation back. All right. So CODAP is basically, it's a tool for data analysis. We are using it for a lot of purposes. On MethdAI, we have, let me show you some modules that we work with on MethdAI. I hope you are already aware about them. So there are a lot of modules which we work in with MethdAI. But prominently, so far, we have actually tried to introduce the tool in statistics, and we are bringing it up in data science. All right. Then, welcome to the session. I'm going to introduce myself in a very short word. I'm a computer science faculty. I've been struggling with information technology since 20 years. But fortunately, I'm yet to give up. So that is a win. I just recently authored 2 books for Staj and Son that is on Essentials of Data Science, which is a skill-based course. And during this, I actually learned that it was very hard to bring data science to the students of class 8th or 9th or 10th because they were not very hands-on with data. So while working with the examples, the only tools that were available were either Google Sheets or Excel, and most of the schools had different variants, various versions of Excel. Then they resort to Google Sheets, but the Google Sheets were not very popular because they are difficult to work as compared to Excel. So then we came across CODAP, and we introduced that on our platform to explore data in a visual manner. And we are actually looking at visualizing without actually having to code. So that was a win over R and other tools. And it in fact uses maps also, which we can be. So we want to learn from the data and master literacy in data using CODAP. So that is basically the summary of what we are going to discuss today. So if you would have any questions, please reserve that for the end. I'll be talking about what is CODAP and how is it useful for the teachers and the students, both alike. So I was intending to actually ask, I thought the session would be very interactive. What is the variable or distribution? Basically, I'll start with statistics. So in statistics, we usually analyze that a data set where a data set is comprised of several variables or attributes, and we can see which particular attribute or which variable is distributed how. Some are normally distributed, some are distributed heavily skewed to one side or the other side, and we usually deal with exploratory data analysis and summary statistics like mean, median, mode. We draw histograms, box plots. There are a lot of diagrams that we draw, and there is another thing that we do besides this, that we have to understand how these statistics are going to be interpreted. That is another issue there. So the tools we use are either Excel or Sheets, or there are some Python or R languages where, but there is one big problem there, that we need to tell the students how to code or how to write functions using Excel. The challenges of the students were difficult, that while there was a stage required where we just wanted them to be able to play with data and let them explore the relationship between that, we were pushing them to actually learn how to code or learn how to uh, analyze that writing a function. So that is where I thought of that there is a possibility of eliminating that hard part of having to learn Excel or having to learn how to write a function or having to learn how to code for analyzing data. And that's where actually this CODAP came into picture. So without actually taking it too further, I'll just actually bring in you to MethdAI CODAP. So on this platform, we have a lot of projects that we are developing. Let us say a very easy or a very basic project for statistics that we developed. Let me demonstrate. It went out with that we have a project module on our platform for birthday club. There we teach the students about that there's 30 students in a classroom. We have a birthday club which celebrates all birthdays, and the students just have to count the number of gifts to be purchased each month. So one student has a responsibility that has been given to it, and to count the number of gifts to be purchased, we need a basic statistical relationship. So they write that in a file. They need to calculate how many gifts are required per month and so forth. So there are questions also on basics of statistics. There is variability in the data, and on the basis of which the student can assess themselves. Then we bring in CODAP using data science, and there is a file that we have. So this is the data which we have already stored in the form of a spreadsheet here. And there are certain instructions which are there with the module itself, where how to create a new document, then how to import a CSV file, and to plot a graph. So this is what they eventually come up to, and they can see that there is a count for each of the month. If they just have to show that with each month how many birthdays are there, with 6 in September, 3 in November, and so forth. So that is a very basic project that we have worked with. Moving from the basic to a bit typical, we are bringing them to even statistical analysis. You would like to see. So there is a project on statistical problem solving, where what we deal with is that we ask the students to collect some data about waiting times when they are at a mall, and then they check if there variability in the data, but what are the factors that cause the variability, because this is the data set they are actually looking at. So they see that average time in minutes is variable, the number of checkout lanes is variable, the day of the week is variable, the hour of the day, store size is fixed, but the customer count is variable. So yes, there is a variability in the data. And then we want to explore what is the relationship between checkout lanes and waiting time. So what we do is we just create a graph, and from the checkout lanes on one side and average waiting time on the other side, then we get a plot. So if we have to eventually see that are they correlated, so there is the degree of correlation actually feasible with simple function that actually allows us to plot it. So this was something. Any more questions can be created? Are there more relationships? Do we need more data for analysis? And so forth. So there may be several correct answers that are feasible there. Right. So this is the part where CODAP works with mathematics so far. I believe if there are any questions up to this point, you may send them to the chat, or we can discuss them later. So there are some more documents that we can import. So I have some documents on my local files, which I was working on. Let us say you are teaching physics to your class 8th or 9th student, and you want to show them the relationship between the current and voltage. So in your labs, usually you are going to ask them to draw a graph on a simple graph paper. But after they have actually analyzed the data and put that into a spreadsheet, we can just simply create a plot of voltage versus relationship, and it shows a linear line where you can even see that they are highly correlated. That means it should have actually been one, but if there are some imperfections in the data that they have collected, so that may be actually bringing in some data to be not exactly lying on the same line. So correspondingly, again, I may actually look for the English language. Let me come up with, yeah. So if a teacher is actually teaching and they want to show that there is a relative appearance of the letters by percentage. So this is from Project Gutenberg. We are taking a total 40,000 letters, out of which they have counted that how many times does each letter appear. So in percentage, the letter E is coming most of the time with 54.8%. That means more than half of your English language words are consisting of letter E, and some letters are very less frequent in your vocabulary or the words. So that was about English. Maybe let me see what we can share more. Okay. So let us say I teach analysis of algorithms in my campus course, ADA. So it's a course where I have to show the student that how the graphs increase. So my graphs are, one is the logarithm, then square of n, the cube of n, then 2 to the power of n. How do these functions grow with each other as the value of n goes from 1 to 10? So that is the kind of functions we can actually allow the students to be able to plot and actually see also. So there is this possibility. And last but not the least, we can actually make a full-blown project where, okay, let me open this for you. This would take a bit of time because there is a large amount of, okay. So check out Free Fall Under Gravity, another physics project that I worked on. There, the students see that what is the relationship between, for an object which is falling in free space under gravity. So one curve is exponential. That means the distance the object is traveling with time is actually increasing rapidly. So because the object is accelerating and the velocity is increasing with a constant bit of time, so they can see what is the relationship between the time and distance on one hand and the time and speed on the other hand. So these were the projects which were simple computer science based interpretation of different subjects. That we had physics, we had probably we can use chemistry, we can use in project on mammals or the student sites. You would like to check this out, that we just had an earthquake in Delhi just some minutes back, and we have a project here which actually shows that how many different type of earthquakes based on the magnitude of the earthquake. We are creating a bar graph here, and we teach them that how do you create a histogram for distribution. So these were some examples where you can see every domain: physics, chemistry, biology, geography. We can cover using literacy for data. And it is important because the data is actually a major part of the lives of all the students, and they want to actually be hands-on with it. So I'm going to demonstrate my last project for today, after which we can have the question. So this is a project which is very close to my development module. The file is a bit heavy, so it takes some amount of time to open. Okay. So this project actually talks about statistical analysis, and we are dealing with a lot of data on the average kids with their heights and their age based on their genders, their BMI, the upper arm length, the pulse, some biological markers of students of a specific age. All right. So we start this discussion with who is taller, males or female. So on my plot, let me create that again for you. So we are actually trying to plot the heights of the students. This is the characteristic that I want to plot. And I want to distinguish it on the basis of the gender. That means I'm distinguishing between the males and females. So from statistical analysis point of view, you'd be able to see that there are some means of central tendency which are capable of actually telling that which of this distribution would have a common marker which is higher. So we take the students to the concept of averages, where they see that the mean for the males is roughly 10 units higher than the female. So we may conclude that the males are taller. But then there is yet another problem, that we can tell them that the data is actually pertaining to ages which are including people who are from 5-year-old onward, and it goes up to 19-year-old onward. So that means my data is actually having a lot of component which is surrounded by people who were just growing, who did not attain their actual height by the time it was stabilized. So we then filter the data by age. That means this is again a facility that we can have on our platform, that we may filter the data only for 10-year-olds here. So if you check out this table, and this, in the previous table we had all ages ranging from 5 years to 19 years. Then we created a filter where we are actually putting in the data. Let me show you the transformer. So from my transformer, we are having age is 10. Data set to filter is between ages 5 to 19. And we are just simply choosing only those students who have age as 10. And this is the data set that we have. And when we compare this, you would be surprised to see that the females are on the average some units taller when they are 10 years of age. So that means the data is not reliable when we take it into entirety. But if we are taking the data only for say 17 to 19 years old, or after a certain age when they have stopped growing, in that case we would be able to, so this is the mean height of male versus female for only over 17 years. There the distinction between the male and the females is pronounced. That means it's not just 10 units, it's actually further more than that. So the student is learning about biology, they are learning about statistics, they are also learning about that there is a correlation between height and weight, which is different for the males and female. For males, the height is definitely increasing more with age. For females, the height is increasing more as a function of age, but slower, a bit slower. So then we also check in the relationship between the BMI, and we can see there are a lot of outliers when it comes to the female, but there are less outliers, and the mean BMI for females is higher than the mean BMI for males. Likewise, there is a possibility of actually taking a lot of huge data, because in statistics we are relying on populations and samples, and then we are working towards central limit theorem to make sure that we have a normal data. So there we are just taking samples from our complete data of 800 cases. We are taking samples of small units there. Let us observe a single sample. So in each sample there are 30 items. If we, by the law of large numbers, if we take a lot of samples and we plot them, so the population and the sample both have the similar amount of data. So there we are study about the law of large numbers, and at the end we can actually show them the use of central limit theorem, which is more like that given any statistical distribution, whatever may be the shape of the distribution, if I take the means of the samples from that distribution, it would be okay. We may have to wait a bit here. The data is very heavy. There is a lot of cases here. Yeah. So there are almost 6,000 elements that we have plotted on this graph. You can see there is a distinction between the mean and the median. That means the graph is actually left skewed for the heights. But if I sample it and if I take a means of all the samples, then the distribution becomes normal. This we can show with the help of our tool, and the students can actually easily understand central limit theorem, which is very difficult to explain in the normal course of work. So this was about how varying uses we can put it to for the learning of your student. I am just leaving this slide open so that if in case there is any question that you may want to ask about the presentation on the data, that we can have. So this was about it. And if there, I mean, beyond the demo, there is just a question of having my mail ID that you can associate with. But I'm looking forward to interacting with you, just looking for any question that you may have, which we can answer. Now,
yeah, can you hear me? Yes. Yes, sir. Thank you. Thank you for the session. Sir, ideally, like when you refer to cross-curricular activities using this technology, what are all the courses that you are suggesting? Like, does it need to be running only in AI class, or we are looking for solutions which can actually run in any class? So your examples, for example, the examples that you gave, even though it is data oriented, even a science teacher can take it, even an economics teacher can take it, right?
Absolutely. Absolutely.
So that is where we are trying to encourage teachers to update themselves on such platforms. At the same time, school also feels that it is not a technology driven classroom. Even in our accounts class also, we teach data driven technologies.
Absolutely right.
So in those lines, what kind of subjects you are suggesting to start with?
Okay, let me share it back. So what we are doing is, as of now, for your teachers or for your students, on MethdAI platform, the statistics module which we are working on, this is actually starting with foundations, takes on to a brief introduction to CODAP, then dot plot, frequency tables, histograms, a basic definition of statistics. So this is the basic can be covered by any student from class 6th onward. Then some portion is intermediate, and we eventually go on to advanced statistics also. And we are relating to all kinds of projects across different domains in the example that we are taking. When you talk about taking it to the teachers, actually, so the use cases are only limited by their own imagination. I mean, I am actually trying to, I am a computer science faculty. I am not into physics or mathematics or stats in general. But when I'm looking at creating examples, I am trying to cover diverse platform so that an English teacher does not feel left out, that there is nothing about data that I can teach to my students, or an economics student for that matter, or an account, or a history teacher for that matter. So in each subject, wherever there is data, wherever there is plot, wherever there is a pattern which needs to be recognized from data, we just need to be able to tell the student that Just experiment, just play with it.
So basically you're summarizing like it depends on the teacher's flexibility, how they can implement this tool in their classroom.
See, this is something, data literacy comes in only when you start using data. It is the only hard part is, the only challenge is that you have to bring the people to just one session, that please try and see how easy it is for you to use. Because okay, I'll relate you to a story about COVID. In 2019, we had every school had that problem, that you just have to move from offline to online. And I had to teach my law faculty, my pharmacy faculty, my management people, that how to use the tools of the trade for teaching online. But then they said, sir, it's very challenging, we can't learn it. I said, just spend a day with me, just one day. That was all I need.
Understood.
Give me one day and I'll let you see so many uses to what you are doing, that you'll be astonished that what can you bring to your classroom. Because see, the students learn by doing. You can send them out to field, you can ask them to collect the heights of the plant and then tabulate it, bring it down, and then use CODAP to analyze that. There is nothing like that. So what they were doing earlier, we just have to actually push it forward, but along with data, because that helps them a lot.
Yeah. Okay. 1 second, sir.
More than 30-40 children are behind us. Our lab is like a workshop now.
I don't mind, it's fine. My lab is also like a workshop. I keep it open for my students all the time.
So that was my question, sir. I understood when I went through the topics that you have shown. What I believe is, it's like not always a technology teacher or an innovation teacher should take the AI classes. Even a commerce teacher, let's say they teach very much in statistics and all, data science and everything. They should also be trained. As you rightly told, bringing those teachers is a pain, but that is my headache. I will 100% bring it. So now, in order to go ahead, like, will there be a demo link or anything that you will be giving to us?
Sir, we can give you a recording of this session. And I trust that I'll have to speak to Ashish. Sir, the demos are easy. You don't ask for a demo link. If you want to bring your teachers to a demo, I'll be available.
No. It is not like that, sir. First, actually, what I will do is I'll spend some time. Then Vivek sir is there. He will spend some time. We need to create a report, submit to the management. And based on that, they will again set the time for the next level of teacher interaction and all. So that's the process that happens here.
All right, let us see if we can, there definitely we can actually prepare a demo according to what are the functions, features.
Some activities. We don't want the complete access and all. We just need.
So I'll do one thing, Vivek, I'll do one thing. I'll create one CODAP activity for you, complete, where you will be guided through 10 different activities, which you can show to your faculty and management, that you can run a live demo. Instead of me, you can run a live demo. So we'll give you access to our platform that you can actually run that particular file on your machine and you can show that running live.
Okay, fine. Got it.
Okay, thank you.
All right. Thank you so much for having me. All right. Thank you for the session, Radha ma'am. I believe that we can close. And we require to discuss this with Ashish, so that what are we looking forward to share as a demo.
Okay, sure, sir.
All right, thank you for having us. Have a nice day.
When you get time, please share the details to our email ID. Then I'll take it forward from there. Not a problem.
Oh, absolutely.
Nice talking to you, sir. Thank you.
Thank you.
Yes.